Port scanning with Nmap. Nmap is one of the most popular, versatile, and robust port scanners available. Some of the Nmap example scans we cover in this module are run using sudo. This is due to the fact that quite a few Nmap scanning options require access to raw sockets, which in turn require root privileges. Let's explore some port scanning examples to get a better feel for Nmap and its options. Accountability for our traffic. A default Nmap TCP scan will scan the 1,000 most popular ports on a given machine. Before we start running scans blindly, let's examine the amount of traffic sent by this type of scan. We'll scan one of the lab machines while using IP tables to monitor the amount of traffic sent to the target. First, we'll use the IP tables -capital I option to insert a new rule into the input chain in the first position. -S to specify a source IP address, which is the IP address we're going to scan, and -J accept to allow the traffic to pass. We'll also add a rule to the output chain. This time, we specify output as the chain and use -D to specify the destination IP address. Lastly, we'll use the -Z option to zero the packet and byte counters in all chains. Now, let's generate some traffic using Nmap. We'll run a default scan by providing the target IP address without any other options. The scan completed and revealed a few open ports. Now, let's inspect some IP table statistics to get an idea of how much traffic our scan generated. We'll use the -V option to add some verbosity to our output, -N to enable numeric output, and -L to list the rules present in all chains. According to this output, the default 1000 port scan has generated around 70 kilobytes of traffic. Let's zero the IP table's packet and byte counters in all chains again and run another Nmap scan. This time, we'll use the -P option to specify all TCP ports. In this port scan, explicitly probing all 65,535 ports, we generated about 4 megabytes of traffic, a significantly higher amount. These results imply that a full Nmap scan of a Class C network would result in sending over 1,000 megabytes of traffic to the network. However, this full port scan has discovered new ports that were not found by the default TCP scan. In an ideal situation, a full TCP and UDP port scan of every single target machine would provide the most accurate information about exposed network services. However, this example reveals the need to balance any traffic restrictions, such as a slow uplink, with the need to discover additional open ports and services. In the next section, we'll explore some of Nmap's various scanning techniques. Stealth SYN scanning. Nmap's preferred scanning technique is a SYN or stealth scan. There are many benefits to using a SYN scan, and as such, it's the default scan technique when no scan technique is specified and the user has the required raw socket privileges. SYN scanning is a TCP port scanning method that involves sending SYN packets to various ports on a target machine without completing a TCP handshake. If a TCP port is open, a SYN ACK should be sent sent back from the target machine, informing us that the port is open. At this point, Nmap does not bother to send the final ACK to complete the three-way handshake. To launch a SYN scan with Nmap, we preface the command with sudo and provide the -S option. Because the three-way handshake is never completed, the information is not passed to the application layer. And as a result will not appear in any application logs. A SYN scan is also faster and more efficient because fewer packets are sent and received. Note that the term stealth refers to the fact that in the past, primitive firewalls would fail to log incomplete TCP connections, combined with the fact that application logs wouldn't catch the scan. TCP connect scanning. When a user running Nmap does not have raw socket privileges, Nmap will default to the TCP connect scan technique described earlier, since it's that application logs wouldn't catch the scan. TCP connect scanning. When a user running Nmap does not have raw socket privileges, TCP connect scanning. When a user running Nmap does not have raw socket privileges, Nmap will default to the TCP connect scan technique described earlier. Since a TCP connect scan makes use of the Berkeley sockets API to perform the three-way handshake, it does not require elevated privileges. However, because Nmap has to wait for the connection to complete before the API will return the status of the connection, a connect scan takes much longer to complete than a SYN scan. There might be times when we need to specifically perform a connect scan, for example, when scanning through certain types of proxies. We use the -S option to start a connect scan. Next, we'll move on to UDP scanning. UDP scanning. When performing a UDP scan, Nmap will use a combination of two different methods to determine if a port is open or closed. For most ports, it will use the standard ICMP port unreachable method described earlier by sending an empty packet to a given port. However, for common ports such as port 161 that's used by SNMP, it will send a protocol-specific SNMP packet in an attempt to get a response from the application that's bound to that port. To perform a UDP scan, the -S described earlier by sending an empty packet to a given port. However, for common ports such as port 161 that's used by SNMP, it will send a protocol-specific SNMP packet in an attempt to get a response from the application that's bound to that port. To perform a UDP scan, the -S option is used and sudo is required to access raw sockets. The UDP scan can also be used in conjunction with a TCP SYN scan to build a more complete picture of our target. In the next section, we'll explore techniques for handling larger networks or networks with traffic constraints.